All right, this is part 2 of the multiple choice questions from the AS Paper 2 from 2019, courtesy of AQA. And this is for physics, obviously. All right, so question 21. Which is the description of the pattern produced when a monochromatic light passes through a very narrow slit? No. Wide central maximum with narrow side fringes. Okay, just what it looks like. Okay, a uniform picture is suspended from a string. What is tension T? Okay, well, there's a reaction force of 20 newtons up there that each of those are doing, and it's, we've got that there, that's 20, but it's split between the two of them, so that's actually 10, and so opposite over hypotenuse, so if I go 10 over t, that is opposite, so that's sine of 30. So t equals 10 divided by sine 30. That's really annoying. It's 20. It's 20. That would feel it would feel wrong. It would feel wrong. It feels so wrong, but it's right, I guess. All right, so 23. Which row contains vector quantities only? Oh man, anybody that got this wrong, you really need to make some flashcards then. Mass, no. Energy, no. Distance, no. Displacement, yes. Momentum, yes. Always. There we go. It's B. Uniform rod is balanced horizontally about a support F. Forces of 400 newtons and 100 newtons act on the ends of the rods as shown. What is the reaction force acting on the support rod at F? Well, it's got to be more than 500. So, all right. Okay, so here's what we have to do. It's a uniform rod. There's a weight right here at the middle. So this is another 1 meter. And there's a weight here. And we don't know this, but I only care about finding F. And I'm going to find F because it's a force acting up like that. And what I'm going to do is take my moments about there. Okay, so I have to look at clockwise and counterclockwise moments. So 100 times 2 is going to add to F times 1. And that's going to be equal to 400 times 2. So 200 plus F is equal to 800. So F is 600. 600 newtons. I could see it getting very easy to get confused and thinking, I've got to take the moments about F because that's where the pivot is. You can take moments about any point. Any point. Pick the one that's most convenient to you, the one that's going to eliminate the force you don't know or don't care about. And I don't care about W, I only care about F. All right, a SUVAT one. 3 objects, U, V, and W, leave the edge of the bench at the same time. The objects fall in the same vertical plane with negligible air resistance. This is released from rest so that it falls vertically. V and W are projected horizontally. The paths of the 3 objects are shown. What statement is correct? Well, they all hit the floor at the same time. They're falling the same distance and they're projected out horizontally. W has a greater horizontal component of its velocity, and since speed is just an overall magnitude of the velocity vector, W does have the biggest velocity vector, so it's going to hit the floor with the greatest speed. Okay, a railway truck of mass 200 kilograms traveling horizontally at 1.5 meters per second collides with a stationary truck of mass 3,000 kilograms. After the collision, they move together. So inelastic collision. So the speed of the trucks immediately after the collision will be, well, 1.5 times 2,000 divided by 5,000. So it's got to be 1.5 times 2,000 divided by 5,000. 0.6. There's a picture of Dennis. So it's 0.6, so no and no, and it's an inelastic collision, so we have a decrease in kinetic energy. Okay, so it's got to be B. 27. A car of mass 1,000 kilograms accelerates uniformly from rest to a speed of 25 meters per second in 50 seconds. The car is traveling horizontally along a road. What is the average useful output power of the car over this period? Okay, so couple of ways that we can do this. I think I'm just going to do the kinetic energy way. Actually, that's pretty much the only way to do this. So the kinetic energy is 1/2 mv squared, and then we divide that by the time. And then we got to divide it by 2 because we're averaging it. Okay, so essentially I'm picturing it like this. So I've got a VT graph. Okay, it's a nice straight line like this. And yeah, okay. Yeah, it's basically just doing kinetic energy, the average kinetic energy divided by time. Mm. 1,000. Divided by time. 50. So we got 6.25 kilowatts there. I really want to divide it by 2. But no, it transferred the kinetic energy, and then I just divide it by the time. So the average power, it transferred that much energy in that much time, so 6.25. I don't have to divide it by 2 again. Yeah, so area under this curve. No, that's distance. That's not what I want at all. So actually ignore my velocity time graph idea. That's not right at all. Yeah. So average kinetic energy. So how much kinetic energy did it have at the end? So that got transferred to it in 50 seconds. So the average power output is the kinetic energy divided by the time. Okay. Tensile force produces an extension delta L in the steel of wire initial length L and diameter D. The same steel is used to make a second wire of initial length 2L and diameter D over 2. What is the extension when the same force is applied? Alright, so half the diameter means 1/4 the area, which means 4 times your stress. And you have an initial length 2L, which means that your extension is going to double just based on that. So you're going to have 8 times your extension. Okay, so that leads to area over 4, which equals 4 sigma. Okay, so yeah, it should be 8 times more. A filament lamp up to its working voltage. It's B. Don't even have to think. Don't even have to think about it. Or at least you shouldn't have to think about it. You should just know what the shape of these graphs are. Alright. 30. 3 identical cells, each of EMF 1.5 volts and internal resistances of 6 ohms are connected to the resistor. The resistance is 6 ohms. What is the current in R? So, this has to do with internal resistance. So, I mean, our EMF is 1.5, okay? And since I is equal to the voltage divided by the resistance, R plus little r. Okay, but little r is not 6 ohms. It's going to be 2 ohms because I've got 3 resistors in parallel, so it's going to make it's going to be 1/3. So that's 1.5 over 6 plus 2. 1.5 divided by 8. 0.1875, 0.19 amps. Okay, so not like, I mean, it's just making the connection that the little r comes from the resistances in here. Okay, you've got an R there, an R there, an R there. They're all connected in parallel. Right? The sum of the little resistances, or the inverse is, it's just the rule for resistors in parallel. Okay, 31. The power of 100 kilowatts at a potential difference of 10 kilovolts is transmitted to a load resistor through cables of total resistance 5 ohms. What is the power loss in the cables? So I need I is P divided by V, so it's 10 amps. Okay. I squared R, so 100 times 5, 500, 0.5 kilowatts. Now, resistors X and Y are connected in series with a 6-volt battery of negligible internal resistance. X has resistance R, Y has resistance R over 2. This is a potential divider question. And essentially what we're saying is that we've got 2 to 1 ratio there. So we're going to have twice as much voltage here versus here. Our 2/3 will be here. So if 2/3 of... Oh, that doesn't seem... Oh, I've got it backwards, that's why. So no wonder I don't have the right answer. So this is the 1 and this is the 2. So this will have 1/3 of the voltage. But that still isn't right. Why is it not right? Alright, I'm going to go straight in and plug it into my potential divider equation, because my math right now in my head is failing me horribly. So, oh, just give me a second. I've got to find my potential divider equation. Oh, bring me my stamp. I was assuming ideal voltmeter, and no wonder I kept getting the wrong answer. So the voltmeter has a resistance of R, which means that my voltage here, or my resistance here, so 1 over... and actually what will be the reading on my voltmeter, because this is really badly designed, will be 2 over R plus 1 over R equals 3 over R. So it's actually R over 3. Which means that my ratio between this section and this section is, if this is 3, this is 1. So it's 3 to 1, or 1/4 of the voltage will be at Y, and 3/4 will be used at X. So it is 1.5. Oh, I definitely need to use my stamp for this one. That's kind of... It happens to all of us. Okay, so 33. The reading on the voltmeter halves when the switch S is closed. What is the internal resistance of the cell? Well, it's got to be 2 because it's having it. So that's really not even a one where you have to do a whole lot of calculations. I mean, you can do the calculations if you want, but if it's having, that means that this potential divider is half. So they're equal. They're equal. Current in the 5 ohm resistor. Okay, so that means that this series configuration is 8. This series configuration is 8. That means that this configuration is 4 ohms. Okay, so 2 identical resistors in parallel, and you will get half the total resistance. So if that's 4, that means that the total current flowing is 3 divided by 4 is 0.75 amps. Half of that is going to go this way, and half of that is going to go this way because these are equal. So I've got 0.38 amps flowing through there. I don't have to go back through. I have checked my mark scheme each time that I go through it. And I am all right. So apart from that one little instance of having to read the full question, we're all good. All right, hopefully this is helpful.